Solutions are a type of mixture. The properties of a solution depend on the concentration of a solute in the solution. These properties are called colligative properties. Here are 4 colligative properties: boiling point elevation, freezing point depression, vapor pressure lowering, and osmotic pressure. Note that each property is directly proportional to concentration. Stop the video and review these equations and the variables. Let's look at a few applications of colligative properties. You love ice cream. You can make ice cream by adding rock salt to ice to lower the freezing point of ice to make the ice cream freeze. You're driving your car on a hot day. Your car's engine is staying cool because antifreeze is added to the water, which raises the boiling point of water to keep your car from overheating. So far we know that adding a solute to water increases the boiling point and decreases the freezing point. Let's quantify how much the boiling point increases or freezing point decreases. Kf is the freezing point depression constant. Kb is the boiling point elevation constant. These are properties of the solvent. We can look up these quantities. For water, Kf equals 1.86 degrees per molal. Kb equals 0.512 degrees per molal. Let's say we have a 1 molal sugar solution. We can use these equations to calculate the boiling point and freezing point of the solution. I is the number of particles in solution. Sugar is a molecular compound, so I equals 1. Your turn. Stop the video and calculate the freezing point and boiling point of a 1 molal salt solution. And the answer is, for an ionic solution, there's more particles in solution, so the boiling point is elevated more, and the freezing point is depressed more than a molecular solution. Here's another example. 50 grams of salt dissolved in 1 cup of water. Stop the video and review this calculation. For this example, we have to calculate the molal concentration of the salt solution. Let's compare the freezing point of 2 ionic solutions. Stop the video and answer these questions. And the answers are, note that I equals 3 for calcium chloride since it dissociates into 3 particles, 1 calcium and 2 chlorides. Also note that although the same mass of ionic compound is used, the molality is different. Could we use boiling point to see how strong your coffee is? Stop the video and answer these questions. And the answers are, a strong cup of coffee has a higher concentration of solutes in solution that increases or elevates the boiling point. What is osmosis? Stop the video and answer these questions. And the answers are, for this question, the physiological concentration of salt in our body is 0.9%, so you could lose weight by soaking in a solution which is greater than 0.9% salt. Water passes out of your cells and causes you to lose weight. Another colligative property is osmotic pressure. That is the pressure required to stop osmosis from occurring. Stop the video, look at this picture, and answer these 2 questions. And the answers are, remember, water flows from high water concentration to low water concentration. And as osmosis occurs, the concentration on each side of the membrane changes. Oh no, you forgot to put your lettuce back in the fridge and all the leaves are limp. And what about those salty cucumbers in a jar that your friends gave you? Stop the video and answer those questions. And the answers are, so when you leave your lettuce out on the counter, water evaporates from the lettuce, leaving the lettuce limp. And your cucumbers will shrivel up, making pickles. You do this experiment with regular soda and diet soda. A half hour later, one soda tastes sweeter. Stop the video and answer these questions. And the answers are, water will pass from the diet soda side to the regular soda side. Since the volume of solution increases on the regular soda side, the regular soda will taste less sweet, and the diet soda will taste more sweet. You got a big crop of berries in your garden this year and figure you can make some jam. Stop the video and answer this question. And the answer is, water passes from the high water concentration side to the low water concentration side. The military does a lot of research in food and food storage. Stop the video and see how osmosis gives meat a 3-year shelf life. So far we've looked at boiling point elevation, freezing point depression, and osmotic pressure. We'll look at vapor pressure lowering in just a bit. Stop the video and draw a picture that explains why these 3 things occur. And the answers are, For a liquid to boil, the liquid molecules have to have enough energy or move fast enough to escape the liquid into the gas. In a solution, we assume the solute is non-volatile, but the solvent is volatile. That means the solvent evaporates, but not the solute. So when a solution is heated, it's harder for the solvent to escape because the solute is getting in the way. When a liquid freezes, the liquid molecules have to move slow enough by lowering the temperature to get close enough to bond together to form a solid. When a solute is present, the solute blocks the solvent molecules from moving close together so bonds can form to form a solid. In osmosis, water molecules on each side of the membrane are striking the membrane and passing through to the other side. For the side with the higher concentration of water, more water molecules pass through. One way to make clean water is through reverse osmosis. This process uses water movement from a more concentrated solution to a less concentrated solution through a semi-permeable membrane. Stop the video and use this diagram to show how reverse osmosis can be carried out. And the answer is, osmotic pressure is the pressure required to stop osmosis from occurring. Apply a pressure above the osmotic pressure and water will flow in the reverse direction. Other ways to clean water are by distillation, but water has a high boiling point and a lot of energy is required to boil water. Reverse osmosis systems require membranes which can get clogged. Pumps are needed to apply the pressure to reverse the normal osmosis. Pumps require energy to operate and can be expensive. How much pressure is needed? Stop the video and answer this question. And the answer is, plug these numbers into the osmotic pressure equation and the osmotic pressure is 29 atmospheres. Dialysis removes waste and excess water from the blood. Here are two pictures that show the dialysis process. Stop the video and answer these two questions. And the answers are, in osmosis, only water passes through the membrane, but in dialysis, water and other small molecules can pass through the membrane. In the next video, we'll look at vapor pressure lowering and some applications of colligative properties.